Hi everyone and welcome back to the Multiverse of 100 plus data science project series. In this video, I am going to discussing about the pneumonia detections using deep learning. So let's see the demo first. So that's our demo application. If I go on here the choose file and select the images from the normal, let's select this one, open and click here to predict, and you can see the result is normal. Let's go on here again and let's select another photo from the pneumonia. Let's select the first one and click it to open, and you can see pneumonia. How quickly it will give me the response. And this is advanced type of machine learning projects, not deep learning projects. So just follow me along and try to building these uh, applications. Let's see the today's agenda. What are going to covering on this project? So first, you're going to see that how can you load the dataset from our working directory. Then we have the data visualization and also data preprocessing. Then we have the data augmentations and also the resizing of the images. Then you have the CNN architecture. How can you build on CNN architectures using Python and TensorFlow? Then we have the incremental unfreezing and also the fine tuning in order to make our model more accurate. Then we have the evaluating the model. We try to evaluate our model and try to do the testing on our unseen data. Then we have one Flux application that we see earlier in the demo. So without wasting our time, har har mahadev balka start karte detail. In order to building our pneumonia detection model, we're going to be using a dataset from the Kaggle that's called a chest X-ray images. And in the bracket, you can see here the pneumonia. And using this dataset, we're trying to building on CNN architecture and try to predict the pneumonia. And inside this dataset, you can see here this dataset is already divided into the train, test, and also the validations. So we don't need to handle this out. So now, without wasting your time, just go on the Jupyter notebook. So for this project, I'm going to using here the Jupyter notebook. You can also using here the Google Colab, PyCharm, or VS Code itself. Now you can see after downloading the dataset from the Kaggle, I can get here one zip file that's called archive.zip. Now I am going to simply going to unzip it using the Python command. You can also do it manually. And now in the same working directory, you can see here I have one IP1 file, and using this file, I am trying to do the coding part. Well, so this is our IP1 file that we create earlier. Now I am simply going to import here the zip file because I need to also start the file using the Python command. So let's say import zip file. Then I'm going to creating here one instance of the zip file. So let's say zip file dot zip. Okay, you can simply using the tab key from your keyboard. So it will give you the auto suggestions. Now you're giving here the path of that. So let's say archive. Okay, archive.zip. And after that, you need to also store it inside one variable. So let's say jet. Okay, here is it, jet equal to. Now what I'm going to do after getting the file from your working directory, you need to also extract it. So I'm simply going to using here jet dot. So if I press tab from my keyboard, it will give me the auto suggestion. So let's see it give me or not. So you can see here not giving me. Some cases it may be not give, but in some cases it will give, but it will take time. And then we can see after few seconds it will give me some all the method. You can see extract all or extract. So if you press here the extract all, so it will give you extracting all the file inside your working directory, I mean the zip file. So shift enter. Now you can see it will extracting the file inside my working directory. So if I see that, just to white, you can see here some one folder is created that's called chest.exe. Now to try to extracting this file. So it's nothing but 2.46 GB. So obviously it will take 1 or 2 minutes to extracting the file, right? So well, as you can see here, it extracting all the file. If I see in my working directory, you can see a chest extra, and inside the chest extra, I have the chest extra folder, train, test, and also the validations. So what I can do is simply going to delete this one, and also I'm going to using here this train, test, and validations. Otherwise, you can also using it inside your chest extra folder because all of the things are most the same. If I inside go inside this test, you can see normal, and we also have the pneumonia. You can see here the pneumonia. Okay, all of the images. Okay, you can see how many images it have. Okay, if I go inside this chest x-ray, just to white chest x-ray, and now inside this you can see a ds store. So what I can do, I simply going to delete this out and go to this test, delete this out. If I go inside this pneumonia, and now you can see here it having all the files, and same pneumonia, all of the files. Just have a look in the data set. You know, to also look at the data set that if there any uh, inconvenient things is happening here or not. So just delete this out, this DSS store, because you don't need it. Okay, because we're going to load our data set using the OpenCV. So OpenCV is not unable to reading this DSS store. So you need to simply delete this out. Okay, delete this out. Just you need to checking that how you need to getting one new data. You need to also take care of that. Is there any file, which one is not JPG or which one is not a PNG, because we delete the images. We delete the images. So let's go inside this val, and if I try to delete this out, and also this one, and let's go inside this pneumonia and also delete this one. Okay, this is nothing but take care of your data. Okay, now let's check again. Test new normal, you don't have. Pneumonia, you don't have. Okay, obviously inside this train I also delete this out. Okay, okay, fine. That's it. I actually clean our data. Now what I can do is simply going to load our data. So in order to load our data, what I can do is simply going to using here the OpenCV. But before that, let's try to import all of the necessary library which one is required in order to building this deep learning model. So first thing first, I'm going to import here the OS. Import OS. So import OS, because OS is needed in order to get the data from your directory. And we need to also import here the shuttle, because we're going to be using here the data augmentation, so that we need to also replace the data. Then I'm going to import here the random map, it's needed. Then I'm going to import here the numpy as np. So numpy as np. Then also I'm going to import here the pandas as pd. So pandas as pd. Okay, if it is needed. Okay, if it is, because this is nothing but one deep learning task. Then what I can do, I am simply going to import here the cb2. Import cb2. Then I'm going to importing here the scikit-learn. In scikit-learn, there are some classification report, the precision score, the recall, the RC card. We can also use this out. But by default, right now, I'm just simply going to skip this one. Then I'm going to importing here the SK images. It's also called the scikit-learn images. So SK image. Then I'm going to import here the matplotlib. Let's import matplotlib dot pyplot as plt. Okay. Then I'm going to import here the SK image segmentations, the SK image if it is needed. Okay, that's the segmentations. Then I'm going to importing here the cburn. Then import cburn as SNS. That's nothing but for the loading the data set and also data preprocessing. Then I'm going to import here, let's say TensorFlow. It is needed right now. Okay, we later on import it when I try to building the CNN model. It is needed the TensorFlow, the image data generator, like data augmentations things. We can do it later on. Okay. Now I'm simply going to using here the matplotlib inline and try to giving here some floating style. So let's say using here the matplotlib inline. So let's say matplotlib inline. Then I'm going to using here the ggplot as a style. Let's say pld.style.use, and inside that I'm going to using here the ggplot. So let's say ggplot. Simple. So you load all the necessary library just not which are needed for loading the data set and try to do the data visualization and also data preprocessing. Okay. So now what I can do is simply going to load the dataset from our working directory. So we have two levels, pneumonia and also the normals. So let's now levels. So I hope so my voice is quite low because थोड़ा sick हो, fever, cough. So इसलिए हो जाता है. Last 6 days I am not uploading the videos in my YouTube channel. So I decided sick तो लगातार लग जाएगा क्योंकि सीजन ऐसा है. So इसलिए मैंने सोचा क्यों नहीं रिकॉर्डिंग कर लेते. Okay, कहाँ से होगा तो खाट कर देंगे. Okay, normal, and we have a pneumonia. Okay, pneumonia किधर गया. Okay, okay, होगा. Okay, we have the normal and the pneumonia. Those are nothing but two classes. So let's take some shell. Okay, fine. So now what I can do, we simply go into giving here one image size. So let's say image size. So let's say image size. So let's say image size 128. This is nothing but my CNN architecture. When I try to building the CNN architectures, so you need to also giving here the image size is 128. That's why I'm trying to resizing the images. Okay, the same things. Then what I have, it's better we can do it in the same way. I mean the same shell. Then we can define here one function in order to get in the data from our directory. So we have three directory: train, test, and the validations. So that's why I'm simply going to define here one function which will list nothing but call the get data. And inside this, I'm going to using here the data grid as argument. It will take in the data grid. Is it coming from the training data set, or it is coming from the testing data set, or it is coming from the validation folder. Okay, fine. Now first, what I can do is simply going to iterate to all the value from the pneumonia and the normals, because we have two levels. If I go inside my folder, you can see here chest X-ray. Inside have the train. So inside this train folder, you can see it have two classes. So this is nothing but called the levels. So what I can do is simply going to iterate to all the value from my levels. So let's say label in levels. Okay, now we have the levels. We have the levels. So you're simply going to using here the os.path.join. So path.join. So let's say I'm going to giving here the train path. So inside this train path, it will go inside this numerator folder. So simply going to using here the os.path.join. And after that, I'm simply going to passing my data data. So data data is nothing but my training path. Then we having the level. We having the level. So how you try to labeling, I mean how you try to adding this train directory and also pneumonia, we got here all of the images from my directory. From my directory. So this is nothing but my absolute path. This is nothing but my absolute path of the image folder. Now what I can do, we simply going to taking all the class name. So what I can do, you can simply using here the levels dot index, because it will give me some index based on the levels. Based on the levels, it will 0 or 1. Okay. Now let's store it inside the variable. Let's call class name. Okay, class name. Okay. Now what I can do is simply going to iterate to all the images from my directory. So this is mean nothing but if we need to go in here the train directory, then we go inside this numerator folder or the normal folder. This is the code for that. This is my path. Now if I try to go inside this pneumonia folder and try to extracting all the images, what I need to do, I need to creating here one list of that. So list mean it's nothing but a list. So how do I try to getting some value from the list, you're using here one iterator. You're using here one iterator. So let's say for img in os dot listed, and inside it I am going to passing here my path. I mean this path, train and a pneumonia. So you have now all of the images. Now I need to load the images using the OpenCV. So for that, what I can do, I am trying to using here one try and accept block. If there any error, it will try to handle this out. It will try to handle this out. That you see, we remove the ds.store file in our images. So which one is nothing but an exception, because OpenCV cannot read this kind of file, because OpenCV just read the file in the JPG, the PNG or any kind of format, just image type of format. It is not an image type of format, it cannot read it. Now I'm going to using here the cb2.im read, and I'm going to using here my os.path.join. Okay, join and path and also the images. Now our images is getting. Now what I can do, I am simply going to load these images using grayscale. So let's say cb2.grayscale. Okay, grayscale is nothing but the IM read. Okay, you can also using here another technique. You can also giving here 0 or 1. 0 means is uh, grayscale, I mean no channel. Okay, so you can also using this one. Otherwise you can also using this cb2.im read grayscale. That's fine. Now this is nothing but my image array in a bgl format. So let's say image array. So image array, that's it. Now what I can do is simply going to resize our images, because we see our agenda that we're going to simply load the images, and after that we're simply going to visualize and also visualize and preprocessing, and after that you're going to see that the data augmentation, also the resizing. So but first thing first, because I need to also show this data in the matplotlib, so that's why we need to also resize our data. So you're going to using here cb2.resize. Then after that I'm going to passing here my image array. Then I'm giving here my image size. So image size is nothing but 128 comma 128. So using this one 128 comma 128. So we don't need to giving here the channels, because this is on grayscale image also. But when you try to resize it, you don't need to put here your number of channels. So I'm going to using here the variable called resize array. Fine. Now I'm simply going to put this inside one list. Inside one list. So let's define here on list. Let's call the data, and inside this list I have all of the data. So let's say data dot append, and inside this I'm going to passing here two things in the same list. My resize in array, I mean resize image, and then we having the class number. Is it 0 or 1? I mean it is coming from the pneumonia folder, or it is coming from the normal folder. So if there are any if there are any exceptions, so what I can do is simply going to take this out, the exceptions as e. We're simply going to print it out. Okay, we're simply going to print it out. So let's try to printing here the e. Now what I can do is simply going to return, we're simply going to return the function. It will return here one numpy array. We need to also convert this list inside a numpy array because we need to pass it inside also our CNN models. That's why we need to convert this into the numpy array. So shift enter. Okay, so now you can see here it's loaded. Now what I can do is simply going to call this out. So we having the get data functions. So get data function, and inside there it giving the path. So path is nothing but inside my chest x-ray folder, chest x-ray, okay, x-ray, okay, and inside this again chest x-ray. If I see the folder structure, you can see here. I am simply going to use this one. I am not going to use this one. I am simply going to delete this out. Okay, you can also use this out. Okay, uh, yes, you can do it out. Okay, so I'm simply going to using this one, chest x-ray, and this one. Okay, so I'm simply going to go on here, chest x-ray, and after that I'm going to giving here my train path. Okay, so this is my nothing my train path. So this is nothing but my train. Okay, we got the train images. Now simply same as it is, we have in the test and also validation. So let's make it test, and this one call the validations. Fine, and make it test thoda thoda. Then you have the validations. Well, okay, now you can see here it loading the test images and training images and also the validation images inside my directory. Well, now we have the data visualizations and the pre-processing task. We have the data visualizations and the pre-processing task. Now what I can do is simply going to plot our data set, that how our data set look like. So what I can do is simply going to creating here the list directory of our pneumonia. So for that, let's take time. It will take time because it will loading all of the images from the folder and try to do the resizing and also convert them to the grayscale. So it will definitely take time. Okay. Now what I can do, I'm simply going to creating here on plt.figure, and let's giving here the fixed size. So fixed size, and let's giving here 20 comma 10. Okay, we're also creating here on list directory of the pneumonia, that after that you're going to do it for the normal. First you're going to see that the pneumonia images, and after that you're going to using here the normal. So you can also add it inside your research paper or your final your defense thesis, whatever. You can actually add this out, this diagram, because it is needed. Okay, that's how your data set look like. So what I can do is simply going to plot 9 images. So let's say let's plot the 10 images so that we can plot it easily. So let's call range 9. So what I can do using the plt dot subplot. So inside the subplot, I'm going to using here, let's take it 9 so that we can plot, let's say 3 3 3 like that. So it's better take it 9. So let's call 3 comma 3 in the same row and the column, and I'm going to using here the I plus 1 so that it will go after 3, it will go in after the next line. Then I'm going to using here the plt.im show. So let's say plt.first, I'm going to read in the images. So let's say plt.im read. Then I'm going to using the os.path.join. Okay. Then I'm going to using here the directory. So which directory? This is nothing but my pneumonia directory. So let's say creating here one list of that. So pre-pneumonia equal to os.listdir. So this is listdir of the pneumonia inside my training directory. So let's say chest x-ray. Then we have in the train. Okay, it's better we can keep it here. We can keep it here, just those of the images. Okay, those are the images, because we're simply going to plotting this data using this train test and validation, and try to do the data augmentation using the chest x-ray folder. So it's needed. So let's say train. So it is giving me here all of the images regarding the pneumonia. It's loaded fine. So let's copy this pneumonia one, and I'm going to pass it here. Now inside this pneumonia, I need to getting all of the images. So let's say pneumonia dir. So pneumonia directory. Okay, this is nothing but directory of that this images folder. So I'm going to copy this out. Okay, so it will give me the all list of the all of the images for the pneumonia, and this is nothing but a directory. It is if it is needed. Okay, so shift enter is loaded. Now inside this, I'm going to pass here my pneumonia directory. okay, pneumonia directory, and try to taking the images. So for that I'm using here this pneumonia. From the directory I'm taking the first images, let's say first images. Let's making here I, because it will go the first random images, random images from the directory, and try to using here the show it plt dot I am show. Okay, then after that I'm going to passing here my image and cmap equal to gray, because we convert our image into grayscale, so it's better you can see it also in the grayscale mode. Then I'm going to using here the plt dot axis. Let's make it off. Okay, then what I can do is simply going to giving here a title, so title, and inside this title let's giving here the new pneumonia, let's say x-ray. Okay, x-ray images. Then after that we're going to using the plt dot type layout, so plt dot type layout. Then you can also using here the plt dot savefig if you're trying to save this out. So I'm not going to save this out, shift enter. So image is not defined, this image, so it also put it down inside the directory called the variable called the images. So now it will try to plot the images of the pneumonia. Now you can see pneumonia x-ray, all of the images from my directory. So now let's try to plot also for the normal. So what I can do is simply going to copy this same thing. I'm going to pass it here, and I'll also copy this out, and I'm going to pass it here. This is for the normal, so normal, and let's make it normal, and I'm going to also change this one normal. Okay, normal. Okay, fine. So pneumonia, and this is nothing but the normal, and we could also change this out, normal directory and also the normal images. So copy this out. This is nothing but for just adding your data in your papers, so this looks better. Okay, shift enter. Okay, normal directory is not defined, we to also run those out. And now you can see, just wait, it will show the normal images from a directory. Now you can see this the images for having the pneumonia. Okay, and these are the normal images. So this is how you can do the data visualizations of your data. So let's try to also check this out, that how many images are available inside each folder. Let's check this out for the train folder, that just trying to creating here one count plot. Okay, so let's take some shell. Okay, count plot. So what I can do, I'm simply going to track it, let's say for I in train, because we having the variable the train. If I see, and you can see the train, so you have the variable, we're taking all the images from the train. And then what I can do, if it is 1, so let's say if I of index 1 is equal to 0, and it's nothing but the pneumonia, otherwise rest of them is nothing but called the normal. Because if I see inside this train, you can see call the function, and inside this we pass here my class name and also the resize. If it is 1, this means this is the pneumonia, otherwise it is nothing but the normal. So if it's I is equal to 1, equal to index number 1 is equal to 0, that means this is the pneumonia. So otherwise it should be the one normal. So what I can do is simply going to creating here a list of that. So let's say list x equal to empty list, and inside this empty list I'm simply going to append, so list x. Okay, and it also follow the indentation, so list x dot append, and I'm going to using here the pneumonia. Okay, pneumonia. Okay, थोड़ा मिस्टेक हो जाता है यहाँ पर. ओके, न्यूमोनिया. ओके, यहाँ पर है, यहाँ पर भी सेम मिस्टेक है. नियो ओ ई यूमोनिया किधर गया? MONIA. ओ हो MONIA. मुझे जो स्पेलिंग है ना वो इसका थोड़ा मिस्टेक हो जाता है यहाँ पर. कॉपी करते हैं इसको. Okay, now what I can do is simply going to paste it here, this pneumonia. Okay, otherwise it should be the normal. So let's say else, and I'm going to print it out. Let's x dot append, and let's make it out normal. मैं थोड़ा slowly बात कर रहा हूँ क्योंकि नहीं तो खांसी हो जाएगा. Okay, normal. Now what I can do is simply going to do the count plot of that. So for that we're using the sns dot count plot. Sns dot count plot. Okay, then I'm going to passing here my list x. So list x. Okay, now you can see here this is a count plot of the images, and you can see here the most of the images is nothing but uh, up to 350, and you can see normal. There are less number of normal images, but there are higher number of images are which one is having the pneumonia, and localized data set is quite imbalanced. Okay, so what I can do, we simply can do the data augmentations and try to reshape our data. So for that you can using here the TensorFlow in order to handle this out and try to do the data augmentations. So what I can do, I am simply going to do the data augmentations. So data augmentations and resizing because our data, you can see less number of data, we have the high number of data of the pneumonia, but less number of data is cutting but call the normal. Okay, so what I can do is simply going to creating here the image data generator. So for that it also loading here all of the necessary library which is required in order to building this neural detection model. So first thing first, I'm going to importing here the TensorFlow. Let's import TensorFlow STF. Then after that, I'm going to importing here. Let's say from TensorFlow dot keros dot preprocessing. I'm going to import here the image data generator, image data generator. Okay. Okay, from tensorflow.keras.preprocessing.image and importing the image data generator. Then from tensorflow .keras.model, and I'm going to importing here the models. So import the models. Okay. After that, I'm going to also importing here the load model. So from tensorflow.keras.models, I'm going to importing here the load model. I will say that because you need to also do the unfreezing. Then I'm going to import here, let's say from TensorFlow. So let's say TensorFlow.keras.layers. I'm going to importing here the input layer. Then you having the dance layer. Then you having the flatten layer. Then you having the max pooling if it's needed. Okay, pooling 2D. Then you having the cont 2D. I don't think that the count is needed, but if it is needed, we can using this out. Okay, then you have the dropout. But in this case, we're simply going to using here the transfer learning model, and in this kind of cases, the image classification tasks BZ19 actually really working very fine. BZ19 really working very fine. So what I can do, I'm simply going to import this one. So if you have the idea about the CNN, that how can you building the CNN model, you can also use the CNN model also in order to building this pneumonia detection model using deep learning. Even though I also make one tutorial about that before in maybe in any other projects. Like for the brain tumor, we actually the previous one that I do earlier right after 2 years ago, I simply using the CNN. But latest one I upload maybe 7 or 10 years ago. It's nothing but about the transfer learning. You can also check this out, the same things. So let's say I'm going to import it. That's from TensorFlow. So TensorFlow dot keras. Okay, flow में l होना चाहिए. So keras dot applications dot bzz19. I'm going to importing here the bzz19. You can also using here any of the transfer learning model, but I hope that bzz19 really working really fine, and you're also doing the unfreezing and the fine tuning. For the fine tuning, bzz19 give me the better results, so that's why I'm going to using here the bzz19. You can also using here the bzz16 also. Then for that optimizer, I am simply going to using here the Atom. So let's say from TensorFlow dot keras dot optimizers. Okay, optimizers. I'm going to importing here the SGD, stochastic gradient descent. Then you have in the RMS prop. Okay, RMS prop. Then you have in the Adam. Okay, then we'd also import here the callback. Okay, just for stopping the early stopping, so that you don't need to train your model more if it is overfitted or underfitted or not improving your loss. It will try to give here one checkpoint and try to using this callback and stopping these model executions. So from TensorFlow, so let's say from TensorFlow dot keras dot callbacks, and I'm going to importing here the model checkpoint that we have in the early stopping, that we have in the reduce error on plateau. Okay, we're simply going to using it here. Okay, let's shift enter. Now you can see here we have some error. Okay, image data generator is giving here two things. So that's the image data generator. Now if I see that load models or load model, again max pooling 2D from TensorFlow cast.layer, max pooling 2D. Can I import the max pooling 2D from the, I don't think that the max pooling 2D is needed. Okay, it's needed. Okay, keras थोड़ा मिस्टेक हो जाता है यहाँ पर. Okay, now it's still working very fine. सीखो मत, सर काम नहीं कर रहे इसलिए. Okay. Okay, now what I can do is simply going to do the data augmentation and also resizing of the data set. So for that, you're going to be using here this image data generator. So let's take some shell also. And now let's using here this image data generator. So image data generator. And inside that, I'm going to passing here my rescale. So I need to also divide our data set with 255 so that the data set should be normalized in the range of 0 to the 1. So let's say 1 comma 1 not comma 0.255. This is not meant for resizing. Now using this image data generator, you can also generate some new images, just like using the horizontal flip or the vertical flip or the rotations or the shear range or the zoom in or zoom out. Using this, it will creating some images. It will creating some images because you have the data which was really very imbalanced. So to simply balance this out, you need to simply balance this out. Others, if you have less number of data like 100 or 200 images, you can also using this image data generator in order to getting some more amount of data. If you know more about it, you can go on my brain tumor image classification video, just uploaded 7 or 10 days ago. In this video, I discuss every single step like data preprocessing, that if you have just one noise data, how can you handle this out? Quite big, maybe 2 hour long video, okay, with the flux applications. So just go on here and check this out in the same multiverse series. So now what I can do, I'm simply going to using here this horizontal flip. So let's give me here 0.4, 40% of the horizontal flip. Then using here the vertical flip, that's using here 0.4. Then we have the rotation range. Okay, rotation range, let's giving here the 40. Then I'm using here the shear range. So using here shear range, let's say 0.2. Then we have the width shift range. So width shift range, let's giving here same 40%. Then we have in the height shift, okay, range 0.4. It having also zoom in, zoom out. You can also using this out. So let's try to using here the fill mode. So what I can do, I am simply going to fill this mode with the nearest pixel. So I'm going to using here the nearest. So nearest pixel, that's it. So this is nothing but for the training. Okay, so let's make it train data gen. So train data gen. Okay, let's make it data gen. Simple. Okay, now what I can do, I'm simply going to using here the same thing for the validations and also training. So let's validate data gen. So let's make it image data generator, and inside that I'm going to passing here just rescale. Okay, just to do the rescaling because this is the training and the validation data. So when I try to test it out or validate it, you don't need to resize it. Okay, you don't need to resize it because using this training data generator, I'm simply going to do the training part. So that's why inside this training generator, it is needed. Horizontal flip, the vertical flip, the rotation raise, all of the things. Okay. So now what I can do, I'm simply going to do the same thing for testing one. So let's say test data gen equal to image data generators, and rescale and 1 and 255. Okay, fine. So I think that I also upload this video in the times of महाशिवरात्रि, but थोड़ा फास्टिंग था, व्रत भी पालन किया, इसलिए वीडियो अपलोड नहीं हुआ पाया। लेकिन इसका बाद क्या बोलो, फीवर कॉफ बहुत कुछ लग गया, सीकिंग वगैरह। ओके, सो नाउ व्हाट आई कैन डू, आई एम सिंपली गोइंग टू फ्लो दिस फाइल इनसाइड माय डायरेक्टरी। सो थोड़ा गर्म पानी पी लेते हैं। Okay, that's fine. Sorry. Now what I can do, I'm simply going to using this train data gen, and after that, okay, let's try to shift enter, and I'm simply using here this flow from the directory, because this is nothing but one a directory, and using this one you can flow the all the file from your directory. Now inside that, I'm going to passing here my training directory. So training directory is nothing but my chest, x-ray, and again inside my chest, x-ray, and we have in the train. Okay, chest x-ray, we have the train. Well, we have the part of the train. Now to giving here the batch size. So batch size then I have to check. So batch size मेरा system 32 तक ले सकता है batch size. एक also giving here the 64 or 16. It's up to your CPU or GPU, whatever you use. So not using here the target size. So let's say target size. So target size is nothing but 128, 128. Fine. Then I'm using here the class mode. So let's using here the class mode. It's nothing but categorical. Fine. Then we have in the shuffle. Let's try to make it shuffle should be true, so that it can shuffle in the data. And try to using here sheet, because you're using here the shuffle. So 40T as a random sheet. Then giving the color mode. Okay, color mode. Let's using here the RGB. Okay, RGB color mode, red, green, and low. Now let's do the same thing for validation of the testing. Okay, this is nothing but my generator. So let's train generator. Okay, let's try to do it for the validations and also the testing. Okay, also testing one. So better we try to do it for the validations, and we can using the testing in order to evaluating our model. So let's start using here the valid generator and try to pass it inside the variable called the valid generator underscore generator. Fine. Let's try to make it val. Okay, val. Fine. Shift enter, and we having the 5,216 images belonging to classes in the training generator folder, train folder. Now we can simply check if the class levels. So let's say class labels from our train generator. I mean, how many classes are available inside my train generator? Let's say class index or indices. So they give me the class level. So let's checking this one class levels. How many class level we have? We have the normal and the pneumonia. Fine. So let's try to making it inside the class name so that we can pass it inside my basis 19 model. So let's try to creating here one dictionary which one having the value and which one is coming from. Let's say for key and the value. Okay, and also passing here the key. Okay, lambda, and this is nothing but inside my in class labels, but item labels dot item simple. So if we try to check this out, class names, so you can see here 0 is normal and 1 is pneumonia, because थोड़ा उल्टा हो गया है इसलिए. Okay, 0 means normal Okay, third order, you can see here the class name is before the index number, so that's why I'm simply making this out. The 0 means normal and 1 means pneumonia. Fine. So now what I can do is simply going to building our deep learning model, or you can say transfer learning model. So this is nothing but called the BZZ19 CNN architecture. Okay, architecture. Fine. Okay, fine. So now what I can do is simply going to loading here this BZ19 from here. So for that, I'm also creating here one instance of that called BZZ19, and inside that I'm passing my input shape. So input shape, and input shape is nothing but called 128 comma 128 comma 3. Okay, fine. Then I'm going to using here this include top equal to false, because I don't need this top of the BZ90 because it's already trained on the 1000 classes, and this is the custom one. So that's why I'm simply going to dropping this one, this include top equal to false, and I'm simply going to using this weights is coming from the ImageNet, and ImageNet is nothing but on competitions, and by default this BZ19 is already trained in 1000 classes, why it's really very use, and ImageNet is nothing but on competitions. So let's try to making it this called the base model, this mathematical base model, and simply going to using this base model and try to do the predictions. Okay, so what I can do, I am simply going to freezing the comment to avoid the weight updated. First, I'm simply going to making this trainable should be the false, so that it can train if the model is trained before, we can simply making this trainable should be false. So what I can do is simply going to freeze this out to avoid the weight updated. So let's say for layers in base model dot layers. Okay, layers. I am simply going to making this layers trainable false. Let's make it layer. Okay, trainable equal to false. Okay, fine. Now what I can do, I am simply going to creating here one base model and pass it inside the flatten layer, because this is not my output, and try to add one fully connected dance layer. Okay, because we need to also do the unfreezing, so that's why. So simply let's go into using here the functional API or functional model, not sequential model. So let's say base underscore model dot output, and I'm going to using here the flatten. So let's say using here the flatten, and inside this I'm going to passing here my x. Okay, not like that, passing like this way. Now what I can do, I'm simply going to using here the flat. Okay, flat equal to flat, and I'm passing here the x. So this is the nothing but the way of how can you using here the sequential, not functional model. Okay, so now we're simply going to creating here two classifier layer. So what I can do, I simply going to using here the dance layer, so that we can add here one fully connected dance layer. So let's say 4608, and I'm going to using here the activations. It's nothing but call the relu. Okay, I just got it from the research paper. I just giving here this kind of neurons, 406 not neuron, actually nothing but call the filter or the kernel filters, not kernel. Okay, then I'm going to passing here my flat, and I'm going to store it inside the class number one. So this is nothing but my classification layer of the one. Fine. Now we're simply going to using here one dropout. So let's using here the dropout, and I am still passing here. Let's say 0.2, 20% of the numeron should be deactivated for the class number one after the class number one, and let's make it drop out. Okay, drop out. Okay, fine. Okay, drop out. Now I need to also add here another classifier layer. So copy this out, and I will pass it here, and this time the neuron should be, and my filter should be 1152, and this is the class number 2, and I have to do the changes inside that dropout should be come out here and pass it. And after that I'm going to add here one another dropout. We don't need to add here dropout because the last layer, the last classifier, we're simply using the output. So that's the output layer. Okay, output layer should be the of the dance layer. So inside that, I need to giving here how many classes? Two classes. Then I need to using here the activations. So this is nothing but one binary classification. So that's why activation should be the softmax, soft talk max, and then we need to passing here the class number two. So class number two, and then it's pass it inside the output. So output, that's it. Okay. Now let's try to bake a model and try to pass it inside my model. So that's a model, and inside this model, I have the base model dot inputs and also the output. Fine. So this is nothing but my model number one. Model underscore 01. Simple. Now if you try to check in the summary, so model underscore 01 dot summary. Okay, so it will load in the model. If it is the first time, it will download the model from the internet. So make sure that your internet connection should be on. And this is nothing but my model architecture. Fine. Now what I can do is simply going to add here the callbacks and also add here the optimizers. And after that, we're simply going to compile it. And last, we try to training it out using this dataset. Now let's try to do this out. Okay, so that's our model summary that you can see. So now what I can do is simply going to add here the callbacks like early stopping, the model checkpoint, and all the things. So now first let add here the early stopping, then you're going to adding here the model checkpoint. So early stopping, you're going to using here the monitoring as a validation loss. If the validation loss is improving, then we're simply going to stop the execution for the epochs. So what I can do, you're going to using here the early stopping. So early stopping, and inside that the monitoring, I'm going to pass here my validation loss. Based on the validation loss, I simply going to stop that, right? So what I can do, I'm simply going to using here the monitor equal to validation loss. So that's called a val loss. Fine. So now what I can do, we can pass here the verbose. So let's say verbose equal to 1. Then after that, I'm going to give here the mode. So mode is nothing but the minimum number of value. I am trying to maximize this one. So giving here the minimum, and after that I'm going to pass here the patience. I mean, if the patience after the 4 times, if the patience is out of the range, then it can simply going to stop these executions of the epochs. So let's assign it to the variable, let's call the es. Fine. Okay, now what I can do is simply going to add here one model checkpoint. So let's use here the model checkpoint. So model checkpoint. So for the model checkpoint, we need also one file. How are you trying to save here the checkpoint, right? So let's store it inside a variable. Let's call file path. Okay, file path equal to, let's give it a model.s5 like that. Okay, this is nothing but my checkpoints where all of the execution will be stored, and after that you'll try to checking for the early stopping. So I'm going to pass here the file path. So file path. Okay, simple. Then I'm going to add here the monitor. Simple. Monitor monitor is equal to validation loss. So simple loss. Okay, then what I can do, I'm simply going to pass here my save bast only. So save bast only, it should be true. It's just taking the save the bast format, or you can say the bast model in your directory. Then I'm going to passing here my save weight. Okay, save weight only, let's make it true. Okay, you can also make it false if you are not able to saving the weight file. In the brain tumor image classification video, we save the weight. So by default, in here I am not going to save my weight. I'm simply going to using here my model file. Okay, so what I can do, I'm going to using here model weight only equal to false. Simple. Now inside that I'm going to pass here my mode. So let's give it here the mode is auto. Okay, cool. Then inside the save frequency, I'm going to pass in here the epochs. Epochs mean one forward pass and another backward pass. So let's call the save frequency. So save frequency I'm going to giving here, let's say I'm going to give it here which one. I'm going to give it here the epochs. Okay, epochs. Okay, epochs. Fine. Epochs or epoch. Okay. Now what I can do is simply going to store it inside a variable that's called the CP. Okay. Model checkpoint. Okay. Now we need to also add here the reduce LR on plateau, which one is read because for the accuracy also we need to also monitoring the validation accuracy. Based on the accuracy, we can simply going to add here. We can save it. Okay. So what I can do, you can simply using here the reduce LR on plateau. and inside that I'm going to passing here my monitor. So monitor, okay, and inside that I'm going to passing here my validation accuracy. That's it. Now inside this patients, I'm going to give in here, let's say 3 times. Okay, based on the accuracy. Then inside the verbose, I'm going to pass in here the one, and into the factor, I'm going to pass in here, let's say 0.5. Okay, 0.5 as a factor, and the minimum learning rate. Let's give it here 0.001. Which one is convenient, right? Now I'm going to save it inside a variable that's called LRR, and that's it. Fine. Now we need to add in here one optimizer. So let's use here the SGD, the stochastic gradient descent optimizer, and I'm going to using here the learning rate. Let's say 0.001, the by default one. Okay, and I'm going to using here the decay. So decay, let's use here 1 e minus 6. This is the by default one. You can pass it here. Okay, and let's pass here the momentum. So momentum, let's use it here 0, and nest. Okay, nestor ob nestor equal to, let's make it true. Simple pass. Now let's assign into the video. Let's call the fgd. Okay, now simply we're going to compile it. Okay, let's try to compile it. Let's say model underscore 01. So this is our model number 01. If I see it here, you can see model 01, and simply using to compile it. Before you are fitting the model with your data set, you need to also compile this one. So compile based on this categorical cross entropy. This is my loss. So categorical cross entropy. Okay, entropy. That's it. Okay, then optimizers, I'm going to passing here. The optimizer is nothing but called the SGD optimizer. Okay, you can also using the add-on or any kind of optimizer, you can also using it here. SGD. Then inside the matrix, okay, matrix, and I'm going to passing here the accuracy matrix. Simple. So our model compile is done. So now what I can do is simply going to train it out. So how can I train it out? We can simply using here the model underscore 01 dot feed, and inside that I'm going to using here my train generator, and passing here my train generator, and inside the step per epochs, you can also using here the length of your train images. Otherwise I'm going to simply give it here the 50. Just hit and trial, you can also using here the line of the step per epochs. So let's say epochs. So how many epochs is needed? Let's give here 20 epochs. Okay, then callback, and inside this callback things, I'm going to passing here my all of the things that I actually implement, like ECP, and also the LRR. That's my callback. Now inside that I'm going to passing here my validation data. So let's call validations data. So this is my validation data. I'm going to passing here my valid generator. Okay, valid generator, this one. Okay, so I'm not going to actually run it with the 20 epochs. I'm simply going to run it for 1 epochs, and because I already trained this out, so this is my history one, history underscore 01. Okay, so this is the things that you can actually do it out. I don't think that is needed here. Okay, it's obviously take time that you can see, but let's check this out. Is there any error is getting it here or not? Okay, now you can see epochs is running. It will take 2 minutes, okay, to actually running all the epochs. Now you can see it also increasing the accuracy 36 to 39, and loss is 78.01, and based on the loss it will try to optimize, okay, optimize the model epochs. If the patience is nothing but getting for the 4, it will automatically stopping this one. Let's call the model checkpoint, or you can say the callback. Okay, you can say the callback. So after 1 epochs, let's see how many accuracy that we got. Okay, I'm not actually going to plotting here the accuracy curve. That's your task to do that. How can you do that? You can also check my brain tumor image classification video. So here I already discussed about that, how can you plot the accuracy matrix and so on. Otherwise, no problem. I can give here also one clean code where all of the things you can get, like accuracy curve, the RC curve, and all the things. Okay, so now what I can do, I am simply going to save the model in my folder. So for that, what I can do, I am simply going to using here the model weight. Okay, so you can see here inside this, I'm simply going to use here model save weight only equal to false. So I'm going to saving here in is pipe mode. So what I can do, I'm simply going to create here one folder inside my directory where I'm going to simply save this out. So inside that, I'm simply going to create here a folder that's called the model weight. Okay, model weight. Okay, weights. Otherwise, you can also do it using the Python command. Okay, let's also try to do it using Python command. I'm simply going to delete it out. Okay, you can do it manually. Otherwise, you can use here the Python command. That's the main thing that you are a Python programmer. Okay, so what I can do, let's say if not, okay, if not os dot path dot is did mean it is available or not. So let's say I'm going to using here the model weight, model underscore weight, gsts weights. Okay, if it is not inside this path, so what I can do, I'm simply going to create here one directory that's called mkdir, and I'm going to passing here the model weight. Okay, let's pass it the model weight. That's it. Okay, now it's creating here one directory inside my folder. Then I'm going to simply save it, the model 01 dot save, and inside that I'm going to giving here my file path. So let's give here the file path, and inside that I'm going to giving here the model weight, and inside that let's say bzz 19 underscore model underscore 01 dot is like this one. Okay, now inside that I'm going to making the override. If there any file is already available inside this directory, I'm simply going to override this one. Okay, so now let's save it and shift enter. Now you can see it executed this command, and if I go on here, and you can see model weight, and inside that you can see here the model file. Okay, bzz underscore 19 model 01 dot is file. Cool. So our one model is done. So you can see here accuracy is not so good here, just 67%. And I will train this model using that 20 box. So what I'm going to do, I'm simply going to pass here the file that I get after the 20 box. Okay, I actually trained it out before, right? Well, so inside this folder, I'm simply going to paste it here. Okay, replace the destinations. Now you can see this is my file. Cool. So we have the model file. Now you're going to see that how can actually load this file from the directory. Okay. So for that, what you can do, we can simply going to use here model underscore 01 dot load weight. Okay, load weight, and inside that I'm going to giving here my path. So my path is model underscore weight, and inside that let's say bzz 19 underscore model underscore 01 dot is file. Simple. Okay, so this is how you can load your model. So let's take some shell. Okay, fine. Now what I can do, I am simply going to evaluate our model. Okay, that how much accuracy that it got. So for that I'm going to using here the model underscore 01 dot evaluate. Okay, evaluate, and inside that I'm going to passing here my valid generator. Okay, I'm going to simply going to passing here my valid generator. So valid generator, and I need to also passing here the test generator, but we don't create the test generator yet. So what I can do, I'm simply going to copy this out, and I'm simply going to paste it here because I need to also create here the test generator. Okay, I forget to create this one. Okay, let's make it as test generator, and let's make it as a test. Simple. Okay, so shift enter and it will execute it. Now you can see how many images is available inside this folder. So it will give me the evaluation matrix for bzz validation. Let's say eval 01 for 01. Now and it also do the same thing for the testing. So copy this out and paste it, and this is nothing but a test evaluations. Okay, that's nothing but evaluating your model, that how much accuracy that it actually get. So evaluate, and I'm going to passing here my test generator. So test generator, so this one. Okay, so bullet generator, and try to make it test data gen, this one. I'll also change this out. Okay, now you can see how many images is available inside this folder. Cool. So I'm simply going to run this out, and it will take some time because it is evaluating your model. And after that, what I can do, we can get here the validation loss, the validation accuracy, and testing loss, and so the testing accuracy, right? You can see here how many accuracy that it got: 68%, 72% on the testing generator value. So what I can do, I'm simply going to printing all of the things, the validations loss, the validation accuracy, and all the things. So if I am using it here, the first one, it will give me the accuracy for the validation loss. It will give me the validation loss. So let's make it validation loss like this. Okay, we can using here this kind of parenthesis, and we can simply going to pass it here. Okay, so we can pass it here like this way. cut it, paste it here, and we can simply going to add here one f string, and after that you can simply print it out. Okay, so let's try this out. It is really working or not. Okay, and you can see this is the validation loss. So we can copy this out for 3 times again. So it will giving me the validation accuracy. Let's give it here the accuracy. So it will give me the accuracy of the model. So I need to pass in here the one, and after that I'm passing here the evaluation to the testing. So testing loss and the testing accuracy, let's pass it here. Okay, this is the testing loss, and this is the test accuracy. Okay, that's going to copy this out and pass it here. Okay, so after that you can see here we got here the 74% accuracy. Okay, this should be the test accuracy. Okay, test, okay, accuracy. So after that you can see here we got here the 74% accuracy. I mean the this model that passed here inside my directory, we got here 74% accuracy on the model. That's really fine. So now what I can do is simply going to fine tune it. Okay, I am simply going to fine tuning it. You can also do the confusion matrix. You can also draw this out. Don't worry, I will give you the code, the complete code about that. Okay, the clean code, but it will upload it maybe 3 or 4 days later on, because I need to implement this one also, right? So now what I can do, I am simply going to incremental the unfreezing and the fine tuning. So let's call the incremental unfreezing and fine tuning and fine tuning. Okay, not fine. Okay, fine tuning, that's fine. Okay, now what I can do is simply going to create here the base model. So base model equal to bzz19, and inside this I'm going to do the same thing that I do earlier. So let's say include top. So we don't need the include top, and I need to give in here my input shape, and inside that 128 comma 128 comma 3. Okay, fine. And now what I can do, you're going to checking all of the layers of the model. So what I can do is simply going to checking the base model layer. So what I can do, you can simply going to creating here on instance of that the least comprehensions. So let's do it in the same shell. So let's say we having the layers inside my layers. So layer in base model dot layers. Okay, layers, and it's a list comprehension. I'm simply going to iterate to all the value and try to getting the layers name. So layers dot name. Okay, layers dot name, layers dot name for in. So let's save it inside a variable. Let's call the base model layer. Okay, base model layer layer names. It will give me the layers name. Okay, so if I try to copy this one and paste it here, and now you can see this is the layer name. So what I can do is simply going to cutting this on the convolution 3 and the convolution 4. Okay, if you don't know about the incremental, the unfreezing, and the fine tuning, you can go on Google and search for that. How can you do that, right? So this is my layers name. Now what I can do is simply going to taking this output of the layer. So let's say base underscore model dot output that we do earlier in the previous one. So let's say x equal to base model output, and what I can do is simply going to copy this out. Don't waste the time. This one, the same thing we can actually use it here. Okay, same thing you can actually use it here. Just have to changing something inside my model in the later on. Okay, so let's go on here and let's try to delete this one. Okay, and I'm going to pass it here. Okay, but before that I don't need to actually making this trainable should be false, because it already trainable should be false. Now what I can do is need to combine the model number 01 and the model number 02, and the combination is gave me the model number 02. So model number 02 is equal to model, and inside that I'm going to passing him a base model dot input inputs and also the output. Okay, that's fine. Now I'm simply going to load the weight. Okay, so model 02 dot load weight gst weight. Okay, and inside that I'm going to using here my same model weight that you can see here, this same weight. I'm going to load it just like the model number 02, and it will give me the model. Okay, the model file. So model is loaded. So now the main task is here. So first time what I can do is simply going to set our trainable should be false, and in the last true block I am simply going to making this trainable should be true, and after that I'm going to making it false like this one. Let's see how what I'm talking about. Let's say set trainable equal to, let's make it false, by default false. So let's say for layers, layer in base model dot layers. So see, this is the unfreezing technique that you need to do. So if the layers of if the layer dot name in, we have two layers that we see earlier inside this layer name. If I see this layer's name that you can see, just wait. So we're simply going to copy this one, the last two layer. Okay, just last two layer for incrementing and unfreezing. So I am simply going to make it like this one. So first time I am simply going to making this set trainable equal to true. Okay, and after that what I can do, we can simply going to making this, if the set trainable equal to okay, then I am simply going to making this trainable equal to false. So let's say equal to true, set trainable equal to true, equal to true, otherwise I am simply going to make it false. Okay, here is it. Okay, else I'm simply going to make in this set trainable equal to false. This is the technique that you can use in the business 19 to unphrasing and fine tuning your model. Okay, fine. So now what I can do, I am can simply going to printing here my model summary. So our model is ready. Model underscore 02 dot summary. Okay, so right, it will be loading the model, and you can see the model summary. This is my model summary. Okay, fine. Now what I can do, we can simply going to call here our things that we see earlier. Okay, and we can pass here the same things that we do earlier here. If I go down up, you can see you can copy these things. Okay, you can copy these things. You can copy all of the things here. Okay, okay. I'm simply going to copy this one, and I'm simply going to paste it here. Okay, I don't think that it is needed. This only stopping the model checkpoint that you already do it. Okay, we already do it. We don't need it. Okay, fine. Make it model 2. Compile it. Fine, 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 fine. So loss is okay. Now shift enter. Now the same thing. What you can do, we can simply go into training this one. So copy this one, and I'm going to paste it here. Okay. Let's make it history true, and this one model 02, and all of the things are okay. Fine. Train generator step box. Let's make it 10 now, and callbacks and all the things are okay. Fine. So now what I can do is simply going to shift enter and try to run this out. So it will take times to do this epochs. I just give here one epochs, but in your case, it will be using here the 10 or the 20 epochs. That how many accuracy that you can get. And well, you can see here the accuracy is nothing but 83%. So let's try to evaluate it also. So we can copy this out. It also save this out. Okay, just save this out, and I'm going to pass it here, and let's make it model 2 and shift enter. Now you can see it also save it. Let's go on here, and you can see the file. Well, so now we need to also do the evaluation part here. So what I can do is simply going to copy this out. The same thing. Copy. I'm going to pass it here. Okay, the same thing, and to use it here. Okay, this one also. Okay, that's fine. That's fine. That's fine. That's fine. Okay. Okay, this is for the model number 02, and also 02, 02, 02, 02, and also this is the 02, and let's make it 2 and the 2 and 2 and 2. Okay, and it also replace here the file for the 20 pox. I trained it for the 20 pox, and I got here, I don't know how much accuracy I got. Okay, let's try to paste it here, the model weight file inside my directory. So well, I'm going to paste it here, or replace the file in the destination. Okay, let's go on here. Okay, fine. Now I'm going to simply going to using here the shift enter and try to run this out and try to evaluate the model, that how much accuracy got. 68%. Okay, it's increasing. Okay, fine. So I'll back again. So and the evaluation is done. So now you can see here we got here the task accuracy 75% and validation loss is 95%. Cool. So now what I can do is simply going to using it here the unfreezing and the fine tuning the entire network. So let's call unfreezing, freezing and fine tuning the entire network. Okay, entire network. Okay, the last one process. So what I can do is simply going to using here the same thing. It's not so tough to do that. The copy this one and I'm going to pass it here. Just pass it here, and I'm simply going to do some changes on that. I don't know the layer it here. I don't need this one base model layer name. Just need the base model and flatten class number 01 drop out class number 02 and just need to changing here the model number 03. So let's make it model number 03 and passing here the same thing, the base model inputs and the output and load the weight as a model number 3, and I can simply going to remove these things here. Okay, so if I stack this one 03 on, I can get here the model summary. This is model number summary. Okay, so you can see this is model number 2. So now we can simply going to compile it using this one. Copy this one. I'm going to pass it here. Okay, pass it here. Okay, let's pass it here. Okay, and just change this to the model number 03. Okay, so after that what I can do, we can compile the model, and after that we can simply going to feed the model the same way that we do earlier. So we can simply go into copy this one, and after that I'm going to pass it here. Okay, just pass it here, and I have to do some changes on that. Let's say step equal to 100. Let's make it history 3, and let's using here epoxies 1 and pass here all the things. So it will take more amount of time for the epox. So I also already in this out because I'm not going to waste the time. I just need to just change the code, just the code here, just epox number, and you can get here the files. Okay. Otherwise, you can also download the pretend model file that I actually do earlier. You can also using this one. Okay. So this is how you can actually use here the history number 3 and try to save it uh, inside your directory. So how can you save it this one? You can using this command, the same thing. Code is almost same. Okay, you can simply using it here like this way. Just need to changing here 032 to 03. Otherwise, this is nothing but an unfrozen model. So what I can do, you can simply add it just like the BZZ unfrozen. Let's say BZZ unfrozen. Okay, unfrozen like this one. Okay, BZZ underscore unfrozens. That is fine. After the last one. Okay, so you can get here one model file inside your directory. So now what I can do, we can simply go into using this AS5 file to creating here one web applications. You can also do the same thing like evaluating your model. You can test it out. Okay, so after that I got here 93% accuracy after the 35 epochs in the Google Colab. You can also using the Google Colab, but right now I can't do it because I don't have the internet connection right now. अब बहुत डिस्टर्ब कर रही है यहाँ पर वाईफाई. ओके, थोड़ा हॉट वाटर में पी लेता हूँ. क्या बोलूँ? Okay, so that's it. That how can you creating here the model using the deep learning and the transfer learning. Now what I can do, you can simply go into using this unfrozen model inside my web application and try to implement this one. Okay, try to implement this one. Okay, so let's go on here. Let's go on the VS Code. I hope you understand all the code in well. मैं स्लोली भी बात कर रहा हूँ, इसके बाद सीख हूँ, पानी पी रहा हूँ, रैकट कर रहा हूँ, थोड़ा थोड़ा मिस्टेक हो रहे हैं, शायद एडिटिंग पे जाके मुझे कट करना पड़ेगा ना. ओके, काशी भी क्या बोलो, लेकिन करना तो पड़ेगा. Okay, so let's go on the VS Code and try to implement the web applications using this the unfrozen model that we saved earlier, right? Cool. So this is the complete code for the Flux applications, and you can see here I have all the files, the templates folder. Inside this template folder, you can see here the HTML files, and inside the static folder, I have the CSS and the JavaScript file. So don't worry about this code. You can get this code inside the video description of the GitHub link and grab the code from here. And also you can see here I passed here my unfrozen.as5 file inside the same working directory. If I go inside my directory, you can see here this is my directory, and also inside this model weight, and you can see here I also passed here the unfrozen one. Okay, so this is nothing but after 35 epochs in the Google Colab, it will take maybe 2 to 3 hours to train the model. I got here 93% accuracy, which one is very very bad. Not good, not so bad. It's really very good. So what I can do, I'm simply going to use this one and try to creating here the web applications. Okay, so see what actually happening here. We import here the OS, and after that we import here the NumPy, because you need to also convert here the image file into a numpy array, because you're going to using here the CNN, or you can say the transfer learning. Okay, and then we import here the pill. From fill we import here the image, then cb2 and the request the render template, because this is my template, the base template. I'm simply going to using here the index.html and the import.html. If I go inside this import.html, this is nothing but my first part. The navbar is by default static part, and inside this navbar I simply going to using the bootstrap, and inside you can see URL for a static the file path. It will giving me here the bootstrap all the file name inside my css and javascript file. You can see all the bootstrap file inside the css, and all the javascript file inside my javascript folder, and inside that you can see here all the things. Okay, so URL for is nothing but for the Jinja template. You can also using it here. Then we have the index.html, and rest of thing you can see using the extend the import.html. That's mean import.html file is static part. It not changing anymore. In the index.html file, I mean inside this block, it always changing the thing. That's why you are simply going to extend it, and inside this block content, I'm simply going to pass it here my image selections and the loader and also the result. Okay, simple. That's it. Now what I can do, this is the code for that, the app.py. How I'm actually creating any Flux application, into creating here one render, into creating here one folder, let's call the templates, then into creating here a folder called static, the simple into creating here one app.py, which one is nothing but your server. Okay, then you're using here the secure file name, then model and import the flatten, dance, the dropout that you all do all in the code. Then you also import here the BZ19, because we're actually using here the BZ19 to do the classification for the pneumonia. Then what I can do is simply do the same thing that we do earlier in our model file while we are trying to training our model. So you can see here we're passing in the same dance things, the dropout, the dance, and the model, and inside the pass we give here the base input and output. If I go on here, just see, you can see here inside that you can see here all the things. Just go on here, you can see the same things. Okay, that you can see here. Okay, the same thing you can see it here. Okay, so just pass it here inside my also my BS code. So what I can do is simply go on here, and you can see the BZ 19s and same other things. Then we can using here the model 03 in order to loading here the weight. So our weight is nothing but a model bzz unfrozen.h5, and we simply going to creating here one app, the Flux application, and try to print here one loaded. That's model is loaded, check on here. Okay, then we have one uh, method. It's called the get method, and this is an initial route. So where it will taking the input, just the images, and when I click the predict button, it will try to predicting the output that it is a pneumonia or a normal kind of images. So you can see here the request or the method is nothing but the post. That means you are selecting any images and try to predict it out. So it is nothing but one post method. Okay, it's not getting the input from the databases. It's nothing but a post method. It's another post method. Okay, if the post request that method is post, we're simply going to taking the files from my file. I mean from the file. If I go inside this index.html, and you can see here just to wait button predict image upload. Yeah, you can see name is nothing but a file. You're taking this file from this name uh, name input, and taking this, save it inside my upload folder, and I also create here a folder that's called upload, and inside that it will saving this file inside the upload folder and try to pass it inside my get results. Get result actually give me it will pre-process the images, it will edit the images using OpenCV, then it's convert to the array, and then it will try to resize it with the 128 comma 128, because our model accept the input shape is 128 comma 128. Then we need to also convert our array into the numpy that you can see here. Then we're using the expand dimensions. For expanding dimensions, you can also using here the reshaping. Reshaping is needed when you're passing your data inside your CNN model. So reshaping means you have the images, then you have the width, height, and the number of channels. Then we're simply going to predict it out. You can see model 03 that predict and pass here the input images, and we're simply going to taking this Rs max. So it's nothing but giving me the probability of the values. We're taking the maximum value in the axis number one, in the column number one, in the column. Then we're going to simply store it inside the result number 01. And simply going to return our functions. So our function is go return one result number 01. So max is nothing but giving you some integer types of value like me 0 or 1 like this way. So we're simply going to pass it here the get class name because we need to run in string so that it looks like convenient. Now you can see passing here the class number 0. We got here it is 0. That's been normal. Otherwise it's nothing but the pneumonia. Okay. So you can see here these are the results, and inside that otherwise it can be not. Is there any error? Okay. So what I can do, you can simply going to run it from here, and you can see it's up running and down. Okay, return outside the functions. So I think it having some problem. Okay, outside the function result. Okay, let's save it out again. Is there any error? Okay. Okay, and it also saved this out. That's why it's giving the error. You can also using here the Streamlit in order to building this kind of applications. Using Streamlit, you don't need to write this kind of code like HTML, CSS, or JavaScript or Flask server. It will automatically give you some kind of thing. You can using it here to Streamlit and to develop your applications. Later on, I will try to making here one videos regarding the development on the cloud, like Heroku or any kind of platform. I am simply going to use it here. Okay, our file is running up and down. I'm simply going to go on here. I think it is registering the watchdog, the Windows SPI. Okay, let's go on here and follow link. Okay, now you can see here the white screen. Don't worry, it will automatically convert it into the black and the things that you can see here. The invitation using deep learning. I'm simply going to click it here, choose file, and I'm going to choosing the files from here. So here is it. Kidhar gaya, idhar. Okay. So we have the dataset test. Let's take it for the pneumonia, and I'm going to predict it here. Okay. So it will take time. Okay, you can see the pneumonia. Let's try to increase it more. Okay. Let's go on here again, and let's taking some image from the normal. Okay, that's normal this one, and predict it out. And you can see normal how quickly it will give me the response. This is how we can actually creating one pneumonia detections projects using the deep learning and the transfer learning. So that's it for today now, and hope you enjoy this tutorial, and make sure to subscribe to the channel क्योंकि मैं बहुत सीख हूँ इसलिए तुम सब्सक्राइब कर सकते हो, शेयर भी कर सकते हो, प्रे भी करना, राइट, क्योंकि मैं भी शायद 7 से 8 दिन, ओके लेट्स 7 to 8 days later on I'm coming up here again to making this tutorial. अभी भी सीखो, गर्म पानी पीना पड़ रहा है. Okay, that's not the fun. Okay, so that's for today now. Hope you enjoyed this tutorial again, and subscribe this, share with your friends, boyfriend, girlfriend, whatever. Okay, and thank you. Bye bye.